Hello guys, and welcome to the fourth stream about making an animation blending state machine editor. And yeah, that is there was a quite a while since the last stream because I was busy with this change, and I will show you that in a second. I fixed all the stuff that was important for the scaling and for the dragging of the view, and probably could check where is that. It's in here. So yeah, basically I added an ability to apply any transform you want to widgets, and that is very useful for our editor because we will have an ability to scale the canvas and drag it, and yeah, I'll show you when it compiles. So there are quite a lot of changes, like almost 500 lines code that was added. Some was deleted, but yeah, I was promising back then that I will explain what I've done in the change. So I want to yeah, basically go over the changes and explain what I did. But at first I wanted to show you that the changes are working. And as you can see, I can zoom out, zoom in. It still does not zoom to the cursor position, but it is okay. And yeah, you can still drag it, the nodes. And as you can see, when I zoom out and I can click on the node bounds, and that is like works okay. No problems with that. Yeah, but I cheated a bit because there is a bound for the grid. I just made it so it is not infinite, but has some like sensible bounds, and I'm pretty sure that this is enough for most cases, and I probably will just add a constraint for the camera. We'll say that we have a camera here, okay? So yeah, that's pretty much working, and let me explain what I have done in here. So we should start maybe from actually, I don't know if it's the correct way to show you the changes. It is indeed showing what I have changed, but it does not. I can, yes, I can show you the surrounding code too, so no problems. So I've added four new fields to the widget structure, which is the most important. Well, actually, everything is important here. So you have a layout transform, which is arbitrary matrix 3. And there is also a render transform. And there is also a combined visual transform, which is which contains like global coordinates. I probably should zoom it a bit because people will complain again that there is nothing that they can see stuff. So yeah, so this contains the entire chain of transformations. So basically it takes the layout transform, multiplies it with render transform, and multiplies with parent transform. So let me show you that. You know what? Probably, yeah, go back to the unified, because when it's zoomed in, it does not fit on the screen correctly. So I'm still not sure if this let me just show it in here, but again, let me just increase the font size a bit. So probably this, I think, was on the last stream. Yes, so there we go. And in here I have navigation in code, so I can go to widget, and in here I can go to layout transform and find where it is used. It's used in various places, but we are interested in update visual transform. So basically the previous code in here was just like taking the parent global position and adding it to the current local position, and there was this was just a poor man's global coordinates calculation. And now we have something more complex. We including the parent transform in here, and we also include the render transform and the layout transform. As you can see, the layout transform overrides. We are overriding the actual position in here, so we do not take the position from what we have passed in here, because the layout directly tells at which position the widget will be, and we're changing that in here. So also after that we combining everything, and that is recursive. As you can see, this is not recursive, but it uses the stack for to emulate the recursive approach. And we are calculating the combined visual transforms. After that, the visual transform is passed to... No, I probably should... Yes, I should continue with the measure node. So what we doing in measure node, so as you might remember from the previous stream, I have struggled with the transform size method, and it does actually, like, it is actually very, very complex method. It turned out to be very complex. So at this point, when we are measuring the node, we basically need to know the new size for the rectangle that we are having, basically at the probably I should open the Inkscape again and show you that. Yes, something like this. And let me set this to none. And yeah, so by default, when we have the identity transformation, it basically so this is the origin, okay, and the node stands like this when we have the identity transform. And in this case, there's no problems to measure the node. We're just taking the these bounds as bounds for children nodes and continue measurement. But in case if we have a arbitrary transform, then we should calculate these bounds in here. So, and these are the new bounds that can contain the entire transformed rectangle. Okay, and this is what we basically do in here. I cheated again. I just taken the code from the WPF. It is open source. I stated that I didn't write it by myself, and there's quite a lot of code, and basically it handles all the edge cases that can come up. And it calculates everything basically in safe way. So if you have passed some special value like infinity or not a number, none, do this method, it will correctly handle that. So as you can see, it checks for infinities. It checks that the matrix is invariable because we don't need to handle the non-invertible matrices, and it also checks for approximate zero and a lot of stuff like this. So we will not divide to zero and won't get nonce. So it does a lot of stuff. It actually it could be the most time-consuming part of this change if it wasn't available at open source, because yeah, sometimes you can cheat a bit and do not write everything by yourself. There's also another open source technology called Silverlight, and the Silverlight has somewhat the same approach for this method, and in there they do not have the how this should be called, the ability to modify the layout transform, to apply the layout transform for every node. Instead of they having a special node that can apply a transform to the layout. That is somewhat restricting, and I just did what the WPF does, and basically works perfectly. So in case of the where is that, the measurement, we calculate in the new rectangle, then we're using it to perform the measurement. So the available size will this new size is the available size for the widget, and then after we receive the desired size of the entire hierarchy of the nodes, we also performing this. So basically we're taking these rectangle that of desired size that the node has returned, and transforming it again. So, and then we taking the desired size from the rectangle. Basically, that ensures that we have correct size for the rectangle. And the next step is the arrangement. So at the arrangement step, we're doing pretty much the same. So we are transforming the size again by the transform, passing it to the arrange override as the final size. Then we're clamping it to the final rectangle, so it won't have some crazy values like infinity and stuff. And after that, we get in the new transformed rectangle. So basically at the arrange step, we can get something like this. So it can have some offset, because we can get the offset because how should I call that? Because we can have the custom alignments. So we can have the alignment for the x-axis as either left, center, or right, and the same for the vertical axis. So we should take into account the new origin for the rectangle. So that is where it handled. So we're modifying the origin by this position. So basically making that it will rotate inside the that final rectangle. So basically, from its center. Yeah, what else I should clarify in here? Yes, so how we can render this stuff. So in the previous stream, I made a transform stack, which have this this field as a combined transform, and I like skipped that. I just store the transform as it is, and when we do pop from stack, we just set it in the transform to this. We can avoid that, but I probably by this is ineffective. We can just do the stack dot last maybe. Yeah. Anyway, it works, and if it will be slow, it could be optimized pretty easily. So that is okay for now. Yeah, so back to draw the node. When we draw in the node, we at first push in the new the visual transform, which contains the combined transform of every parent. So in case of this window, for this canvas, the parent is the client region of the window, and for the window, the parent is the root canvas of the entire UI system. So basically, it has it combines the transform of this offset from here to here, and from this offset that I can apply by a dragging. So yes, and it renders that at with this transform, but it transforms the vertices directly as it was before. That is needed because we are doing the how it's called, the picking, the selection by a mouse click, and we need to know the geometry of the node. So it does not work just by comparing by checking the containment of the mouse point inside any node bounds. It just checks it does the full check against the geometry of the node. So in case of this node, the geometry will be this border, and in case of text, it will be a lot of small rectangles. So yes, so this is pretty much the changes that was done in here. Nothing special. And if we'll go back in here, yeah, so I also changed how the clip bounds are calculated. So the clip bounds are basically telling you, not you, but the render and the entire UI system where are the bounds of the node. So in case of this window, the bounds are yeah, the window bounds. So this rectangle. But in case of canvas, we're basically assuming that it is infinite plane. So in this case, we can use, where's that? The special flag called, sorry, I got lost in my own code. Yes, the special flag called clip to bounds. And by default, that flag is true. So every node that will be rendered as a child of some other node will be clipped by parent bounds. So if we will try to move this text outside of this node, it will be clipped away. But if we will have this flag as false, then it will be not clipped. So it is especially useful for canvases like this, because they essentially have no bounds. We can like do this, a lot of dragging outside of the view bounds, and do this, and yeah, it's pretty much infinite plane. And that affected pretty much everything, because previously there was just screen bounds that was used for clip bounds and for picking restriction, so we can't click on a node like so. So you can see how much the node goes outside of the window. So that clip bounds also prevents from selection of the node outside of the bounds. So the UI library clips this this rectangle by a parent rectangle, and prevents that from being selectable or clickable, and so on. So as you can see, there are quite a lot of changes, and that was like a few days of work. So that probably wouldn't fit in one stream, and yeah, usually on stream you have to talk much, and you don't have like enough concentration to think. So yeah, so from this point we can probably go on GitHub and oops, not like this. Yeah, I think we can merge that. All checks have passed. Merge that. All right. And delete the branch. All right. Now we can stop this. I want to switch to the master again. With the changes. And in here I have some other small changes that I have started working on. Basically, I changed how point to local space works. Previously, we used this trick, which like it works, but it is less generic than this one. So in here, instead, we just take in the visual transform, which basically the transform that was used to present stuff on screen, and we inverse that and apply that to a point. So we transform in the point using inverse transform, and that gives us the coordinates of the point in local space. So and it used to transform cursor position to local space of the canvas, and that works exactly the same as before. Probably I should yes, probably do this, because it takes a lot of time to build the release build. Yeah, these are GitHub hooks, if I'm not mistaken, and they're working pretty fast. So yeah, today we probably will implement yeah, let me think what I want to implement today. Yeah, the debug builds are incredibly slow. Yeah, probably we should stick to the release mode, unfortunately, because the debug builds and the editor in general is very slow in debug. Right, so probably today we will do the transitions between the nodes. All right, so that will be transition. Let us add the transition in here. And the transition node, the transition will be a widget too. So we need to create transition, a new structure. That will be widget. As usual, we implement the control trait, transition, and a bit of copy paste, 1/3. Like so. Get this, put that in here, and also we will take this and put that in here. And of course do this, and also it requires that to be clonable and buggable, I think. What else is missing? Let's check. Sorry. All right, back on track. That was my phone. Yeah, so cannot find. Right. Use std. What's the oops, ref and the ref. All right. So in here we also should have a draw, and in here we will draw the arrow. And I'm still not sure how to do this correctly, because why the handle was imported from here? It should be imported from what? I'm pretty sure that, yeah, there's a lot of why it was imported. It's strange. That Rust plugin does some weird shit sometimes. All right, so we need to decide how to store the connections between nodes. Probably, yeah. The naive approach would be just storing No. The node should not know about transitions, but the transition should know about nodes. And that will be source handle UI node and the destination node. So the destination and source node. All right. So also we need a transition builder. Transition builder. And we'll have the widget builder. Widget builder. Implement transition. No, transition builder. New self base. And then here we will have the build as usual, the self, and the context. Build context. And we'll turn the handle to UI node. Transition will be, yeah, something like this. Context add node, UI node, new. Right, and widget builder build, and that will be the default for some time. Okay. So, now we need to think how to connect transitions to nodes. Whether that should be the functionality of the transition itself, or maybe some other like transition manager like this. Yeah, probably the easiest approach would be to delegate the creation of the not the creation, but the reconfiguration maybe to the transition itself. But we also need a way to create the new transitions. And probably that should be some widget inside the node. Also, this node will not be like this is not the final state of the node, because we will have some other type of nodes, and that type of node will be the node with sockets. And by socket I mean like small. Let me show you that on simple drawing. And god damn it, what's that? God damn it, this freaking editor. something like this. So basically these are sockets, and that is like these are input sockets and these are output sockets. So in case of some blending nodes, we'll have something like this. A single input, a multiple inputs and single output, and there will be also some parameters. I don't know, maybe in case of if it is blend by index node, then there will be a parameter that somewhere in here, the parameter that supplies the index that will select the animation from one of the sockets and pass it to this node, to this socket, and somewhere outside to other nodes. So and for transitions, there will also be, yeah, probably I should draw this, and I don't know. Yeah, let me do this. Why is so wide? So, all right. And then here, I just want to make a mock-up for this. So this is the one kind of node, and the other one will be like the no, this is insane. 10 maybe, yes. So and this will be the state. So state node will have this border will be a place from where we can start creating a new transition as basically no, not this. Please. So, yeah, all right, like so. So that will be a transition from one node to another. What the hell is this? Like so. And in case of these nodes, the transition, not the transition, but the connection will be something like this, the Bezier curve. Probably could have seen such stuff in other editors, so there is nothing new in these pictures. So and you can have arbitrary amount of nodes in here and arbitrary amount of nodes state nodes in here, and any amount of transitions, and also the transition will have its own properties. So yeah, there's a lot of stuff to do. In general, I think this editor will take maybe a few weeks to make at least working prototype. Let's go back to this. All right, so yes, probably we should implement this method, which will draw the arrow, and I think that's pretty much straightforward. So push line. Uh-huh. Is it straightforward? I'm starting to doubt it. All right, so the problem is that we need to know the positions of these nodes, but in draw we cannot fetch that. It does not provide any access to the to any other nodes. So now we have two options basically, to pass another parameter in here, which will mean that we need to modify the UI library, or we can go to we can probably add the update method that will it also won't allow us to fetch the position of the nodes because it does not provide the UI to it. So yeah, so probably we would not have any other options, but add the new parameter in here. Or oh, actually, imagine that we starting to create the connection, the transition. So we are doing something like this. So we have clicked on here and starting to create a transition between 2 points. That will force the transition to have the destination field to be empty, and that won't help much. Alternatively, we can do what the Unity does. Basically, right click on the node and select create transition and click on another node, and I will do it. Probably that is the simplest way. Yeah, I think we should start from something simple, not to do this animated or how we can call it, not animated but interactive creation. So click here, drag, start creating the transition, put mouse in here, release the mouse button and attach. Probably like context menu, create transition, click on the destination node, and the transition is basically done. That is, I think, preferable. What is indicated that there is a transition? The arrow indicating that there is a transition from one state to another. And there also will be like options for the transition, like the parameter that tells whether the transition should start. Yeah, let's do this because it's much more simpler, and also Probably we should also have, oh, not this. Source position, and that'll be vector 2, 32. That will be this position. Like so. And also we cannot have we will not be able to know the source position at the build stage. So probably we should go to canvas, add the I don't know, the maybe not even in here, but in the editor itself. Canvas node, and the canvas. Where's the canvas? This. Let canvas be equal to this. Canvas. And here we should have update. And that will take the UI. So yeah, let me explain what I'm doing right now. So we need to somehow synchronize these fields with the real positions of the nodes, because when we created a transition and filled in these values, we can then move the nodes by dragging. So we need to somehow sync the position of the transitions. One way of doing this would be to modify these fields when we drag in the node that has not by dragging the node when it has no what I'm talking about. Modify when we're dragging the node, we should find every transition that have this node either on destination or source, and then modify its source or destination position. And yeah, probably this is not needed then. That's hard. Will the second state not appear? I mean, by transition, I mean by states, I mean, how can I explain that in this with simple words? Imagine a person that has two states, where one when it is running, and one when it is like idling, and these are states. So when we transition in from running to idling, the states, the animations will be mixed proportionally. So we will have smooth transition from one state to another. So basically, it will look like the character was moving, and then it have stopped, like so. I hope that explained. that explain the stuff. So yeah, we can do that in here then, in the routed, in the handle routed message. Where is the dragon context? All right, in here. So in here we should find every transition that is on the canvas for child in self children. If some transition equals to y node child just equal transition. So if that is if the child is transition, then we should check whether the transition I think that should be public source equals to entry node or transition destination equals to entry entry node. And in this case, maybe we should, probably we should split that. Yeah, so if it's on source of some transition, then we should send a message to that transition. Yes, so we need to define the message first, indeed. Yeah, let's steal that from here. That's somewhere in here, and that will be all right. So yeah, this prefix is pretty much useless. All right. Transition message, and in here, this in here, and source position vector 2, and in here it will be this position. Source position, and source position. That will be this position. That will be this position too. And we also need to handle these messages. If it's some message equals to message data. I also need to cast that to transition message. So we have some transition message, and if the message I don't know what I'm writing. So if the message destination equals to self handle and message direction equals to message direction to widget, then we should check what the message we have. So the source position, in this case, we need to set source position to position. Yeah, the reference, and in this we should do test position. All right, so now we can send the messages. That will be transition message. Source position. And that will be child. Message direction widget, and the value will be so the value will be what the value will be, the new position maybe. That is the simplest approach to get the position directly in here as the new what am I saying? To set the position as the new position, that will basically point to the top left corner of the node, but ideally we should point not to the left corner, but somewhere I don't know, maybe yeah, to the center probably. Yeah, the center will be the good position. So in here we should calculate the center, and the center will be the new position plus y node entry node actual size scaled by this. That will be the center. And for the destination, we should do pretty much the same. All right. Destination position. What else? Let's check the comments. But how does that apply to the two squares with the arrow? I was somewhat distracted earlier, so I don't know if the first square is different to the second one. All right, so let me explain that again. So this is the running animation, and this is the idling animation, and this is the transition between two. So when we start the transition, you can like track how much of the transition have happened. So if we start in here, the result will be the closer to this state than this. So we will have more of running than the idling, and when we will be in here, there will be half of this and half of this, and we'll be in here at this state, then we will have only the animation from it. I don't know, I should probably create some example in Unity to demonstrate that, because it's somewhat hard to imagine. But yeah, I hope I explained it a bit. All right, so the next step would be I don't know. Yeah, we should have the yeah, the context menu probably to create the transitions. But before that, we should create some utility methods in here, resource, self, source, handle, node. So what the hell? Source, test. So source, self, test, test. Okay. Self source and self source. Oh no, not source. What am I doing? The destination. All right, so now we can start adding the new context menu, and that context menu will be in single instance, and it will be controlled by the editor itself. So I have reverted the changes, and the context menu node context menu will be hello. Why no? So node context menu will be. So what the context menu should look like? We should go to world, maybe. Yeah, there is menu. So there is an example of how to create the context menus. Let's copy paste that shit. Okay. Like so, with just one menu item. So why we creating a single instance of the context menu and not creating the context menu per node? Because it's too expensive. Imagine if we will have some like 100 nodes and there will be also 100 context menus. That is crazy. We can reuse the context menu since we can have it opened only once at a time. So yeah, it's just the same way to do things. Menu item builder, and I'm pretty sure that there is a shortcut for that. Menu item content text, and that will be create transition. Create transition. Create transition. Something like this. Also, we need to have a way to create nodes. So we should where is the canvas builder? No, it's probably here, right? Right, exactly. So just delete this, and we also should have a separate context menu for canvas. Canvas. So we need to create nodes by like right-clicking and create node, and that will be canvas context menu. That will be create node. Not create node. Create no. Create state. What am I smoking? create state, and yes, and probably right now we should create canvas context and create that. Implement that. So context build context and self. All right, so in here we should have that will be menu, and that will be create state. Please cooperate. Create state. Create state. All right, so create state, and the same stuff for node context menu. Node context menu, and in here we will have pretty much the same. Yeah, let's move this out. In here, create transition, that will be menu, self. Okay. Canvas context menu will be this. Node context menu will be this. And you context. Wait. Node context menu, new context. All right, so all right now. Yes. So god damn it, we should create first. Let canvas context menu will be this, and in here we should. Where's the with context menu, canvas context menu. So let's check if that compiles. It does not. It does nothing for now. But at least we should see we should see the canvas, and when we right click on it, we should see the context menu. And the context menu shouldn't be affected by any offsets or scale, I mean zoom in, and what's the context menu? This is the context menu. So you're right clicking and this is the context menu. All right, I'm waiting for nothing. Yeah, we should write. We should also write the handler for the messages that comes from context menu. So when we click on create node, it will create node. And also, yeah, on previous stream I probably mentioned that we should also prepare the data model for this. So yeah, what's the common approach when you create something? Then you create it inside the model, inside the data model, and then you synchronize the UI state with that model. So when you create a new node, then you create it first in the data model, which basically your data, and then you ask the UI to sync to that data model. So the UI, like, it does not hold any state. I mean, the does not hold any data that is related to your data. So it is completely detached from your data. So this is the context menu, and that works okay. So now we should handle that. That will be handle UI message self in here. What I will have in here? The message, and what else? All right. So, if let sum. What is the yes, the menu item message click equals to message data. If message destination equals to self create. All right. That's not that's not what I want. Or maybe why it's called the create. All right, it's create state. Fuck, damn it. I'm confused by my own code that I written a few seconds ago. Yes, the context menu is the right click menu. It's called context menu. Sorry if you didn't know that. I confused you. So when we click in the create state, what we should do. So I want to basically do everything correctly from the start. So probably I should yeah, I should create. Yes, I should create the command stack right now. Otherwise, it will be like I don't know. I have like half an hour left for the stream, so maybe I'm tempted to do this in a dirty way to just show what I was trying to achieve. So yeah, I'll do that off stream. So that is not so interesting. Probably yes. So when we click in the create state, sorry for that. We should go and create a new state, of course. So the UI that will be the immutable user interface. And here maybe sm state no builder new widget builder new build. Context will be UI build context. Oh, that will be node handle. Node handle, and it will also be some yes. So we need to link that to the canvas. Right. So right. So yes. The handle UI node and the be in public. This is all is dirty way of doing things. I will refactor that off stream. I will explain why it is dirty after on the second stream. Because it is yeah, it's just a bit too long to implement all that stuff. I mean, the data model and stuff, and not so interesting. So in here we should do this: send message, widget, message, link. And I always forgot what it does. Link with. Ah, right. So we need to link the node handle. Direction. We should link that with self canvas. All right, that's great. And mutable. Canvas. Canvas. Yes. And the canvas context menu should know about the canvas. Like so. Alrighty. And that's pretty much it, I think. If it compiles, it should work. Oh no! It will not work because we are not calling this. Should go to where is that? There's so much code. For fuck's sakes! All right, it should be in. All right, it's something in here. BSM editor handle. Why I cannot use the function? All right, because should do this self handle message why proxy that basically, and that will be message, and that will be mutable and user interface. I said that's great. Yes, it will have all possible actions. Yeah, this is just called context menu, which basically means the set of context actions. Yeah, you should use you should directly use the handle UI message. Basically, it is called the handle UI message is called. There is no magic. It is called from here. Basically, you're telling the UI to process the next message, and it returns it to you, and then you are free to use it as you want. Basically, you are just entering this method, and then you continue your handling in various places. In this case, we will continue in here and checking if we have a message from the context menu, and we do some stuff if you have clicked on the create state. So it should work now. What it complains about? All right, it complains about transition builder that is not used. Indeed, it is not used. It will be used later. Probably not even today, because I spent a lot of time explaining stuff. Probably tomorrow I will do the extended stream, maybe for 3 hours, and then I will do what I wanted to do. All right, so voila, that works. But as you can see, it creates nodes on at the origin, somewhere in here. Where is the origin? And ideally, we should create the node where we have clicked. So in this case, we should do, yeah, we should do this. Let me show you. So we should get the position of the context menu. So why I don't need, oh no, I need that. It was mutable. Yeah, so let's do this. Let's get the node self menu and take the screen position. All right, screen position. And now we need to take the visual transform of the canvas. So y node self canvas visual transform. Then we should inverse that. Try inverse unwrap or default and transform point, and that will be point to from screen position. What the screen position, that will be quartz, and that will be local position, and with desired position, like so. And that should create the node at the correct position. So what it does basically takes the screen position of the top left corner of the context menu, and then it uses the canvas transform, the inverse of that transform, to basically put that screen position into local space of the canvas, and the canvas will be created at the point where we have clicked, and I hope that will work. It should work. Yeah, that works perfectly. And if we'll zoom out, that will be at the correct position too. So yeah, the magic of math is working. So yeah, basically we should just continue with the transitions. All right, so now we should continue the transitions, and right, so when we create in the new node in here, we should pass the context menu for it. With context menu, and the context menu will be the handle of the node context menu. So this node context menu, and node and self node context menu. That will be default for now. And in here, we should go and put no, not this, and that will go in here. And in canvas, context menu, node context menu will be equal to node context menu. All right, that should do the trick. And we should see the different context menu when we'll click on the node. And that will basically should tell us that we are able to create new transition. the same approach will be to design and UI. What do I mean by design UI? Design and UI. I mean the UI designer, like Visual Studio Blend, or how it's called in the Qt. I can't remember. But if you have used that, you got the point. So, all right, as you can see, oh shit, how it works. To drag and start working for the right click. But if you look closely, when we will click in, when we click in on the canvas, we can create state. But if we will click on the state, it will ask us to create a new transition. But it does not work for now because we should handle that in here. Yes, in here. All right. Yeah, let's get that. Put that in here, and the create transition. In this case, to create transition should probably I don't know, maybe switch the state of the editor to create transition mode when it will block all interactions until we create a new transition, something like that. I need to think about this. Ideally, it should look like we're creating a new transition, attaching it to the source node, which will be the node that we have just clicked, and then when it is, we should remember that the handle of that transition, and then if we still have a like transition being created handle to that, we should constantly like pass the new destination position to that transition by sending a message, and then when we will click on some node while we have a transition being created is still active, we should like confirm the creation of that transition. Yeah, probably that is the correct way of creating stuff. But I need to think how to implement that. Still not sure. All right. No, yes, you can do that. No problems. You should just try to use that, and you probably like. I think I've built quite a powerful UI system, or in the engine. I'm basically improving it for 3 years now, so it should be like capable to do like crazy stuff. So as you have seen, you can rotate your window and still be able to like drag some scroll bars and stuff. So you can try and use it, and probably you will be surprised how flexible it is and powerful. I should probably also post it somewhere on Reddit maybe, or somewhere else. But yeah, what stops me from that is that yeah, basically has no documentation, and we'll be struggling for some time because the documentation is very fragmentary and yeah, like tons of methods that have no description. So back on track. Yeah, let's do what I can do right now. Probably we should create. Yeah, I should remind you that I have like 10 minutes left, and probably we'll continue tomorrow. Yes, in case of lines, the transition will be just a line with the arrow at its center. So in this case, we should use what is it? All right, so self source position, self disposition, and thickness will be maybe 2. And from context, commit self clip. All right, there was a problem. So the clip bounds should be, I don't know. Yeah, let's cheat a bit, and I'll be new 0 0 0 and 9999 999.0. That will basically mean that it won't be clipped unless you have unless you like working on that in the future when you have 10K monitors and stuff. So should work until that time. So as the brush, we'll be using one of the, probably that will be the foreground brush, and the texture will be none. The clipping geometry will be none too. And we also need to draw an arrow. I probably yeah, I have this arrow primitive. What does that mean? What does this function do? All right, so make arrow primitives. What's the primitive? All right, it's just basically a set of points. Vector image. Draw. Right, so to make an arrow, probably should have arrow node, which will be the vector image. So there will be the vector image builder, new widget builder, new field context. If primitives, make arrow primitives, arrow direction. What is the default direction? Probably it's right, right? Right. Oh, the left, right. And the size in local coordinates, that will be like 10 pixels or units. Oh, I just realized that that the layout transform could be used to improve maybe the like the high DPI monitor support. I should try using that because some guys complaining about that for quite a while. The editor does not support high DPI monitors, and everything looks so small. So probably, yeah, probably I will continue tomorrow. Sorry that I didn't create a transition. I didn't show you that, but I promise you that I will do that tomorrow, because I need to do the boring stuff that will include the it will include the data model and stuff. So yeah, let me finish with that, and I will end the stream. One message. All right. Yeah. So thanks guys for watching, and yeah, I'll see you tomorrow on the next stream. Bye.